ओके अभी कंफर्म करना, इज द ऑडियो क्लियर, वीडियो क्लियर एंड एम आई लुकिंग हैंडसम? इज द ऑडियो क्लियर, वीडियो क्लियर एंड एम आई लुकिंग हैंडसम? ये तीन चीजें आप कंफर्म करके बताना। इज द ऑडियो क्लियर, वीडियो क्लियर एंड एम आई लुकिंग हैंडसम? ये तीन चीजें कंफर्म करना। AVH, ऑडियो तो क्लियर है, वीडियो तो क्लियर है, और ये भी बताओ कि एम आई लुकिंग हैंडसम और नॉट। ठीक है, तो yesterday we were converting NFA to DFA, right? Yesterday we were converting NFA to DFA. Yesterday we were converting NFA to DFA. है ना? है ना? So can someone in the Telegram group post the question that we did yesterday? एक बार can someone in Telegram group post what we have discussed yesterday? Hello? एक बार टेलीग्राम में सब लोग कोई एक लास्ट प्रॉब्लम हमने क्या किया है वो शेयर करना। एक बार टेलीग्राम में हमने लास्ट प्रॉब्लम क्या किया है वो शेयर करना। हमने लास्ट प्रॉब्लम क्या किया है वो शेयर करना। ठीक है, ठीक है। सो आज वी आर गोइंग टू कन्वर्ट ए DFA टू minimal DFA. A DFA to minimal DFA. We are going to convert a DFA to minimal DFA. ठीक है, ठीक है। We are going to convert a DFA to minimal DFA. आपको जगदीश चंद्र बोस के बारे में पता है? He did the wireless communication in 1895. He did wireless communication in 1895 and he did it before Marconi, but Marconi has got all the credit, है ना? And he is not satisfied with physics, so he invented crescograph, a device measuring plants growth at micrometer. मतलब जगदीश चंद्र बोस ने ये इन्वेंट किया है कि प्लांट्स का भी लाइफ होता है, ठीक है, और वो भी क्लॉक पार्ट्स, मतलब जो भी क्लॉक में पार्ट्स होता है ना उसे यूज करके, और ग्लास ट्यूबिंग्स को यूज करके, और मेटल को यूज करके, बहुत ही कम प्राइस में, बहुत ही लिमिटेड रिसोर्सेस में ये बहुत अचीव किया है, ठीक है। एंड हिज वर्क इज पब्लिश्ड इन इंग्लिश एंड बंगाली। अगर आप में से कोई बंगाली है तो एक बार जगदीश चंद्र बोस का बुक्स मिलेगा तो बंगाली में पढ़ लेना, मजा आएगा, ठीक है। और जो भी इंग्लिश आता है, इंग्लिश में बुक पढ़ना मजा आएगा। आई रेड हिज इंग्लिश बुक्स, दे आर ऑसम। मतलब हाउ ही स्ट्रगल टू डू एवरीथिंग, दे आर ऑसम। तो मैं इसमें से लेसन क्या मिलेगा भाई? परसिवरेंस एंड रिसोर्सफुलनेस कैन ड्राइव ग्राउंड ब्रेकिंग इनोवेशंस इवन अंडर कंस्ट्रेंट्स। मतलब ये कंप्लेंट मत करो कि भाई मेरे पास पैसे नहीं है, मेरे पास टाइम नहीं है, ये मैं बहुत ही यंग हूँ, मैं ये नहीं कर पाता हूँ, वो नहीं कर पाता हूँ, रीजंस मत देना। परसिवरेंस होना चाहिए, परसिवरेंस होना चाहिए, ठीक है। लिमिटेड रिसोर्सेज से भी आप अच्छा रैंक ला सकते हैं। मैं ऐसा कोई स्टूडेंट्स को IISc में देखा था जो विदाउट कोचिंग टॉप 100 में आए थे, अपने आप खुद प्रिपेयर किया विदाउट कोचिंग, ठीक है। और आपको कोचिंग भी मिल रहा है, आपको फर्स्ट रैंक क्यों नहीं आना है? फर्स्ट रैंक आना ही चाहिए, है ना? इतना अच्छा कोचिंग देते हैं हम लोग पीडब्ल्यू में, तो आपको फर्स्ट आना ही पड़ेगा ना। ठीक है, तो अभी हम देखते हैं कन्वर्शन ऑफ डीएफए टू मिनिमल डीएफए। ठीक है, कन्वर्शन ऑफ डीएफए टू मिनिमल डीएफए। आप सब लोग ये कॉन्सेप्ट के लिए वेट कर रहा है, मुझे पता है। आप सब लोग जब से मैं डीएफए शुरू किया हूँ यही क्वेश्चन पूछते थे कि सर आपको कैसे पता है कि ये मिनिमल डीएफए है। वो आज हम करेंगे। ठीक है, दरवाजे को गुंडी मारो कोई ना अंदर आने पाए, आरबीआर को समझा दे म्यूजिक गलती से भी रुक ना पाए, टकर टकर जो फील करे जाके 2 कप कॉफी पी ले, जिसको डांस नहीं करना है जाके अपना बैस चराए, अभी तो पार्टी शुरू हुई है। ठीक है, जी भर के नाच ले बेबी, नाच नाच के तोड़ दे सैंडल, आंटी पुलिस बुला लेगी तो आरबीआर कर लेगा हैंडल, डांस विथ माय ट्यून्स। दिस इज दी वेरी इंपॉर्टेंट, दिस इज वेरी इंपॉर्टेंट कॉन्सेप्ट। और गेट में क्वेश्चंस भी आया था, थोड़ा सा मुश्किल है, मैं इजी बना देता हूँ, डोंट वरी। ठीक है, थोड़ा सा मुश्किल है, मैं इजी बना देता हूँ। ठीक है, थोड़ा सा मुश्किल है लेकिन मैं इजी बना देता हूँ। ठीक है, तो if a DFA has if a DFA has n states, if a DFA has n states, then minimal DFA then minimal DFA has less than or equal to n states। अगर DFA में n states है तो मिनिमल DFA में लेस देन और इक्वल टू n states होंगे। ठीक है, और two states are equivalent, two states are equivalent two states are equivalent if they both either go to a final state, or a non-final state. If they both either go to a final state or a non-final state on all strings, ठीक है, इसके मतलब क्या है, बोथ स्टेट्स शुड बिहेव द सेम। आपको एक ग्रीक एंड लैटिन समझ में आएगा, जो भी मैं लिख रहा हूं आपको कुछ भी समझ में नहीं आएगा, मैं बताता हूं। बोथ स्टेट्स बिहेव सेम मतलब ये क्या है, दो स्टेट्स इक्विवेलेंट है। कब इक्विवेलेंट है, इफ दे बोथ आइदर गो टू फाइनल स्टेट और नॉन फाइनल स्टेट ऑन ऑल स्ट्रिंग्स। ठीक है, अगर दो स्टेट्स ए कामा बी है, ए कामा बी दो स्टेट्स है, अगर दोनों स्टेट्स जो भी स्ट्रिंग देंगे आइदर बोथ गो टू फाइनल स्टेट और गो टू नॉन फाइनल स्टेट, अगर ऐसा है तो बोथ आर इक्विवेलेंट। ठीक है, बोथ आर इक्विवेलेंट। ठीक है, ठीक है, आई गो इनटू वेरी हाई डेप्थ, वाईटी में आई गो इनटू वेरी हाई डेप्थ। ठीक है, ठीक है, अभी ये बताओ, ये बी को हम ए कामा बी दो स्टेट्स है, when can we say that they are equivalent? When can we say that AB are equivalent? When can we say that AB are equivalent? We can say that AB are equivalent if for all strings belonging to sigma star, all strings belonging to sigma star, delta star of A comma W and delta star of B comma W both go to either final state or non-final state, either final state or not final state. ठीक है, ठीक है, लेकिन ऐसा इक्विवेलेंस को फाइंड आउट करना थोड़ा मुश्किल है, तो मैंने थोड़ा सा सिंप्लीफाई करता हूं. ठीक है, हम ना क्या करेंगे कि ए कामा बी और ए कामा बी और के इक्विवेलेंट, ए कामा बी और के इक्विवेलेंट if a comma b are k equivalent if for all w belongs to sigma star and mod w less than k, less than or equal to k, mod w less than or equal to k, both A and B, both A and B either go to final state or non-final, either go to final state or non-final state. ठीक है, हम के इक्विवेलेंस के बारे में बात करेंगे. इसके मतलब क्या है, आप के से भी you have to give strings which are less than or equal to k, and then you have to test if both the states are going to final state or non final state. इसका मतलब क्या है, k लेंथ स्ट्रिंग से भी कम ले लेना. mod w should be less than or equal to k, मतलब k लेंथ से भी कम लेंथ स्ट्रिंग्स लेना और देखना कि both are going to same state, both are going to final state or non final state, both are going to final state or non final state. ठीक है, कभी कभी ना अल्गोरिथम्स को यूज करने का जरूरत नहीं पड़ती है. मैं आपको एक क्वेश्चन देता हूं, 5 मिनट का टाइम देता हूं, आप ना, आपको मैं अल्गोरिथम समझाया नहीं, आपको अल्गोरिथम पता ही नहीं, आपको अल्गोरिथम पता ही नहीं, मैंने समझाया भी नहीं, लेकिन लेकिन आप फिर भी कर सकते हैं क्वेश्चन यूजिंग योर इंट्यूशन. ये डेवलप करना कि हर एक क्वेश्चन के लिए अल्गोरिथम को ढूंढना और सॉल्व करना, ये मत करना. ठीक है, हर एक क्वेश्चन के लिए मैं एक क्वेश्चन दे देता हूं. ओ दिस इज इंग्लिश बैच राइट, this is English right, I am getting confused, sorry. I will give you a question, and you are supposed to answer the question without using algorithm. ठीक है, challenge, will you take the challenge that I will give you a question, you don't know the algorithm now, but you should be able to answer the question without using the algorithm, by using your intuition. Just by looking at the finite automata, you should say the answer directly. I will give you 5 minutes of time. Don't write it in Telegram now. I will, when I tell you, then write it in Telegram. For now, I'll give you a question. Okay. For now, I will give you a question. Okay. So the question is going to be like this. The question is going to be like this. Okay. I'm giving you a DFA. Use your intuition and try to solve it. Use your intuition and try to solve it. I will solve it with algorithm also. Use your intuition and try to solve it. ठीक है. ठीक है. I'm turning off the comments. Don't write it in the comments. Don't write it in the Telegram group. For 5 minutes, don't do anything in Telegram group. Okay? Don't do anything in Telegram group. I'll ask you, then only you answer it. Try to analyze it for 5 minutes. Okay? Thank you, Orange. अभी आंसर करना कितने स्टेट्स आए हैं। अभी आप आंसर करना कि कितने स्टेट्स आए हैं। कोई नहीं कर पा रहा है क्या? ये तो बहुत ही सिंपल क्वेश्चन है। ये तो बहुत ही सिंपल क्वेश्चन है। वेरी गुड। इसके लिए एल्गोरिथम अप्लाई करने का जरूरत ही नहीं है। क्यों? अगर अगर if you see a zero, see this, you don't have to apply an algorithm here. If you see a zero, then everything is accepted. 1 is accepted, 0 is accepted, 1 is accepted, 0 is accepted. If you see a 0, everything is accepted. If you see a 1, everything is rejected. 1 is rejected, 0 is rejected. Matlab, you can simply write it like this. If I see a 0, everything is accepted. So I can simply write like this. And if I see a 1, then everything is rejected. Hana, this is intuition, common sense. What is 𝐂𝐸𝐴𝐶S? 𝐂𝐸𝐴𝐶S is common sense. Hana, you don't have to do anything. If you see a 0, everything is accepted. If you see a 1, nothing is accepted. So this is becoming a small, very small DFA. This is becoming a very small DFA, but don't worry, sometimes you will not be able to solve it. So that is why we will discuss the algorithm also. If you apply the algorithm, you will definitely be able to solve it. Okay, let's try to apply the algorithm. Okay, अभी तो पार्टी शुरू हुई है। ठीक है, ठीक है। पहले ना हम ऐसा लिखेंगे, जीरो इक्विवेलेंस। जीरो इक्विवेलेंस मतलब we are not going to see anything and we are going to classify the states into two categories. Okay, let us call it as pi naught. Let us call it as pi naught. ठीक है, in pi naught what are there? In pi naught what are there? One is A, D, E and the other one is B, C, right? So what did I do here? Non-final states, I kept them in one partition and final states, I kept them in one partition, right? Now let us go to pi 1. Pi 1 means what? 1 equivalence. Okay? Now I will try to see, on seeing one symbol, they are actually going to be differentiated or not. Okay? On seeing one symbol, whether they are going to be differentiated or not. Okay? 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 So first I will test whether A and D are equivalent. Okay, I will write like this, A, D. Okay, I will see on 0 where they are going. A on 0 is going to B. A on 0 is going to B, right? And D on 0 is going to E. D on 0 is going to E, right? A on 0 is going to D, D on 0 is going to E, D on 0 is going to E, right? Now if you observe it, if I write AD, if I try to write AD, A on 0 is going to B and D on 0 is going to E. They are going into different partitions. Whenever they are going into different partitions, you have to separate them out. They are not equivalent. A and D are not equivalent. let us separate out A and D. A is in a different partition, D is in a different partition. Now we have to check whether E goes to the same partition or not. Now we have to check whether E goes into the same partition or not. Now we have to check whether E goes to the same partition or not. Okay. So let us see A and E, whether they go into the same partition. A and E, right? On seeing a 0. A and E on seeing a 0. A is going to B and E is going to E, right? Now if I see A and E, A is going to B, A is going to B and E is going to E. Again, they are also going into separate partition. Therefore, A and E are not in the same partition. Delete it. A and E is not in the same partition. Delete it. Right? Now, let us see if D and E will go into same partition. A is not going into same partition with D or E. Now, let us see if D and E are going into the same partition. Okay. So how can I test if D and D are going to the same partition? How can I test if D and D are going to the same partition? DE on 0, D is going to E, D is going to E and E is going to E. If you observe it, both are going to the same partition, which is E in this case. You have to test for 1 also. DE on 1. On 1 D is going to D and on 1 E is going to, and on 1 E is going to E. E is going to E, right? So again, both of them are going into the same partition. Therefore, they are equivalent as of now. Put them like that. D comma E, put them like that. Okay. Now let us see if B and C are equivalent or not. How can I test it? I will take B and C and I will see where they are going on 0. I will take B and C and I will see where they are going on 0. Where they are going on 0, right? Where they are going on 0. Where is B going on C? Where is B going on 0? It is going to C, right? Where is C going on 0? It is going to C, right? Both of them are going to C, right? So B and C, both of them are going to C, which means they are going to the same partition in the previous partition. They are going into the same partition in the previous partition, right? But then you have to check for 1 also. B and C on 1 where they are going. B on 1 is going to B, B on 1 is going to B and C on 1 is going to B. B on 1 is going to be and C on 1 is going to be, right? So both of them are going to be only. Both of them are going to be only, which means they both are equivalent as of now. Again check for pi 2. Again check for pi 2. Now A has become separated, so there is no need to check. Now you have to check DE, where they are going. See this? Where is DE? DE on 0 is going to E. DE on 0. DE on 0 is going to E. And DE on 1 is going to DE on 1 is going to DE. Again, both of them are going to same state. So I am going to put them together, right? Now what about BC? Now what about BC? What about BC? What about BC? So what about BC? B, C, can we put them together is the question. Now see this. B and C on 0 are going to C, same partition, and B and C on 1 they are going to B, same partition, right? Therefore they are going into the same partition, so there is no, you cannot separate them. Now if you observe it, pi 1 and pi 2 we got the same one. Pi 1 and pi 2 we got the same partitioning. A, D, E, B, C. A, D, E, B, C. Pi 1 and pi 2 we got the same partition. A, D, E and B, C. A, D, E and B, C. A, D, E and B, C. Right, right. So shall I explain it again? Now what does this say? This says that there are only three states. You can combine D and E. This says that there are only three states. One state is A and DE can be combined. DE can be combined and BC can be combined, right? And A on 0, where is it going? A on 0 is going to B and A on 1 is going to D and B on 0 is going to C and B on 1 is going to B. Here also D on 0 is going to E and D on 1 is going to D. That's it. We got only three states. This is a difficult question to understand. How many of you want me to repeat it? This is a difficult question to understand. How many of you want me to repeat it? Please tell me how many of you want me to repeat it. How many of you want me to repeat it? How many of you want me to repeat it? Or shall we take one more example and do it? Do you want me to repeat the same question or do you want me to take a different question and explain it? If you raise your hand, what can I understand? Tell me, do you want me to explain this question once again or what do you mean by me? Are yaar, yes, no, how can I understand? Write a line. Repeat, sir, or don't repeat, sir. If you say me, how can I understand? Can you please tell that we cover the PYQs, top level questions as well, all concepts? Yes, we will cover PYQs. We will cover everything. We will cover everything. Okay, some people are asking for me to repeat it. I will repeat it. Okay, I will just go and get some hot water. Meanwhile, you just go through it. Some people wants me to repeat it. I will repeat it. Especially my fan number 2 is asking, so I have to repeat it. Okay, I will repeat it and I will do new questions also. Let me go and get hot water. I will just come. Okay. Meanwhile, you just try it. Meanwhile, you just try it. Okay. So 𝐂𝐨𝐮𝐬𝐞, can you arrange a webinar in your college? Guys, if anyone wants webinar in your college, DM me in Telegram. I will conduct a webinar. Guys, if you want a webinar in your college, please do DM direct message in Telegram. Please do direct message in Telegram if you want me to do a webinar in your college. Okay, it will be very interesting. We can discuss a lot in the webinar rather than doing it in the class. Okay. Suryajesh, try to see if you can arrange a webinar. Okay. And please don't call me God of TOC, because I am already God of computer science. Okay. I am not God of TOC. Sir, your Telegram ID. My Telegram ID is RBR. Okay, I don't know my Telegram ID actually. It is there. I am one of the admins in RBR Sir PW. In RBR Sir PW, I am already there. If you want any webinar, you please DM me directly. Okay, we will take a webinar. Okay. Yeah, I do motivational speeches in Hyderabad. If you can come to one of my speeches, then you are always welcome. Okay. So now let us see this. A 0 B 1 0 C 0 1 D 1 D 1 E 0 E 0, 1. ठीक है. First step is you write pi naught. Step number 1 is you write pi naught. What is pi naught? Zero equivalence, which means you put all the final states in one partition and all the non-final states in other partition. Okay. So you put all the non-final states in one partition. What are the non-final states? Non-final states are A, D and E. A, D and E. And what about the final states? Final states are B and C. Final states are B and C. A, D and E, and final states are B and E, B and C. Okay. Now you are going to write pi 1. In pi 1, we have to check whether in pi 0, these two are equivalent, these three are equivalent, these two are equivalent. Now we have to check whether they are equivalent in pi 1 also. How can I do that? I will take AD and see if they are equivalent or not. I will take AD. Okay. I will take AD and I will see where it is going on 0. A on 0 is going to be A on 0 is going to be, and D on 0 is going to E, and D on 0 is going to E. Right. Now if you observe it, A is going to B and D is going to E. Both of them are going into different partitions. Whenever they are going into different partitions, they are not equal. You have to separate them out. Okay. A and D are not equivalent. We have to separate them. So A is here, D is here. Now I want to see whether E is equivalent to A or E is equivalent to D. So that is why I write AE. That is why I write AE. Right. AE on 0. Where is A going on 0? A on 0 is going to B, and E on 0 is going to E. E on 0 is going to E, right? So if you look at AE, A is going to B, and E is going to E. Again, both of them are going into different partitions, so write them separately, which means AE are not equal. AE is not equal, but let us see if DE is equal. If DE is equivalent, right? For that I have to write DE. We have to write if DE is equivalent. Okay, we have to write if DE is equivalent. D on 0 is going to E. D on 0 is going to E, and E on 0 is going to E. E on 0 is going to E, right? And now DE on 1, where is it going? So D on 1 is going to D, D on 1 is going to D, right? And E on 1 is going to E, right? Now let us see DE on 1. D on 1 is going to E, D, and E is going to E, which means both of them are going into the same partition. So you can put them together as they are equivalent. Now let us check if B and C are equivalent. How can we check if B and C are equivalent? I will write like this: BC on 0, B on 0 is going to C, C on 0 is going to C, C on 0 is going to C, right? So both of them are going to C, right? Now BC on 1, now B on 1 is going to B, B on 1 is going to B, and C on 1 is going to B. Both of them are going to the same state. Here both of them are going to C, here both of them are going to B. Both of them are going to same state. Therefore, these two are equivalent. A is in a separate state, DE are equivalent, BC are equivalent. Do one more time. Do until no changes happen. A is a single state, write it like that. Now we will test whether DE is going to the are equivalent or not. Now see this, DE on 0 is going to E, DE on 0 is going to E, and DE on 1 is going to D. DE on 1 is going to DE, D and E is going to E. Both of them are going to the same partition. Both of them are going to the same partition. Both of them are going to the same partition. So they are equivalent. Now what about this? B, C. Are they equivalent or not? Now if you see BC, both of them are going to C on 0, and both of them are going to 1, are going to B on seeing a 1. Therefore both of them are going into the same partition. So we can say that B and C are equivalent, right? So what are the equivalent states we got? A is in one state, DE is in one state, BC is in one state. If you observe this, pi 1 and pi 2 didn't change. Even if you write pi 3, you will get the same thing. So you can stop there. Whenever you got the same thing, you can stop there. Whenever you have got the same thing, you can stop there. Whenever you get the same thing, you have to stop there. Whenever you are getting the same thing, we have to stop there. Okay. Whenever we are getting the same thing, we have to stop there. Let's stop here. Now what did we get? We got three states. One state is what? A. Other state is what? DE. And other state is what? BC. Other state is BC. Other state is BC. Right? Okay. Now how to put the transition? See this. A on 0 is going to B. Therefore A on 0 will go to B. Now A on 1 is going to D. Therefore A on 1 will go to DE. dE. Now B on 0 is going to C. B on 0 is going to C. Right? Now B on 1 is going to B. Therefore, B on 1 is going to B. Now, what about this one? D on 0 is going to E. D on 0 is going to E. Right? And then D on 1. D on 1 is going to D. D on 1 is going to D. D on 1 is going to D. Right? 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 So we have minimized the finite automata. Okay? Okay? Everyone got it now? Sir, can we compare them using transition diagrams? Yeah, we are comparing, right? Using the transition diagrams. We are comparing. So, will you do one more example? I will give you 5 minutes time. I will give you one example. I will give you 5 minutes time. Try to solve that, okay? I will give you 5 minutes time. I'll give you one more example. Try to solve it, okay? Try to solve it. So, solve this one. Okay, take 5 minutes time and solve it, okay? Take 5 minutes time and solve it. How many states you got? How many states you got? Can you write your answer in Telegram? I will see where you have gone wrong. TOC के लेक्चर्स पे लिमिट नहीं है, जब तक हम परफेक्ट नहीं होता है तब तक मैं लेता रहूंगा. देयर इज नो लिमिट ऑन TOC. I will solve lot of problems. I will solve hell a lot of problems. Okay. And when you say, sir, enough, we are very confident with TOC, I will stop TOC. Till then, TOC will go on YouTube forever. Okay. Till you say to stop, I'm not going to stop. Very good. Shashank, very good. ठीक है. I will do it. Just see this. I will do it. Okay. I will do it. First, you write pi naught. Final states and non-final states. Final states are AC and non-final states are BD. Final states are AC and non-final states are BD, right? Now let's see pi 1. I want to see whether A and C are still equivalent or not. I want to see whether A and C are still equivalent or not. Now A and C you see on 0. A and C you see on 0. A and C you see on A, right? Now A on small a is going to B and C on small a is going to B. Both of them are going to same state. Both of them are going into the same partition, A and C. Right. Now A and C on 1. A and C on 1. Where are they going? A is going to A and C on B. A and C on B. A is going to A. A is going to A. And C is C on B. Where is this transition for C on B? There is no transition. Here there is a transition. That is missing. That is why you didn't get the answer. Right? So this is not a DFA. Earlier it was not a DFA. You didn't tell me that it was not a DFA. We can only convert DFAs into minimal DFAs. Okay. So C on A is going to C. Now on B, A and C are going to AC. Now on B, A and C are going to AC. A and B or A and C are going to AC. A and C are going to AC. कंपाइलर डिजाइन का अभी अपडेट नहीं आया है, देखते हैं. मतलब कंपाइलर डिजाइन का अपडेट नहीं आया है अभी तक मैनेजमेंट से. मैनेजमेंट जो बोलेंगे वो मैं करूंगा. ठीक है. तो डी एंड बी एंड डी को देखेंगे. बी एंड डी. तो बी एंड डी ऑन ये वेयर आर दे गोइंग? बी एंड डी ऑन ये वेयर आर दे गोइंग? B and D on A, where are they going? B is going to D. On A, B is going to D. On A, B is going to D. And this is A, this is B. Okay, there are some mistakes in the question. And now D on A comma B, D on A comma B is going to D only, right? So both of them are going to the same state, no problem, right? Now B and D on B. Let us see on B where A, B and D are going. B is going to C and D is going to D, right? So 1 is going to C, B is going to C, and D is going to D. Therefore, these two have to be separated out. A and C are equivalent and B and D are not equivalent. B and D are not equivalent. B and D are not equivalent. Okay. So pi 1, so pi 2, they are not equivalent. A and C are not equivalent. A and C are equivalent, B and D are not equivalent, right? Right. Now there is a change. Here B and D have got into separate states. So you have to do one more time. Till they don't change, you have to do it, okay? So now let's see pi 3. In pi 3, where is A and C going? A and C are going to B and AC, right? So A and C are going to B, and A and C are going to AC. A and C are going to AC, right? Both are going into the same state. On A, both are going to same state, and on B, both are going to same state, right? Right. Therefore, A and C are equivalent. And B and D are already separated out. You don't have to do anything. B and D are already separated out, and you don't have to do anything. You don't have to do anything. Right. So finally I got AC, B and D. Finally I got AC, B and D. And pi 2 and pi 3 both are same. 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 Right, right. So what can we say? We have three states. One is AC, other is BD, one is B, and the other one is D, right? Now A on B is going to A only, and A on A is going to B, and B on small a is going to D, and B on small b is going to C. B on small b is going to C, and A and C are final states, right? A and C were final states initially. Now also there will be final states. So finally we got this. So this is the minimal DFA. This is the minimal DFA. Okay? Will you do one more question? I will give you one more question. Try to solve that question. I will give you one more question. Try to solve that question. Try to do for this. Prashant, doing one more equivalence doesn't hurt. Doing one more equivalence doesn't hurt. Okay, before you do this, I will share you a story of a hero. Okay, you will get refreshed. Okay, before you do this, have you heard about C.V. Raman? He was born in 1888 and he was born in 1970. He discovered something called as Raman effect in 1928, proving that light scattering in molecules shift the wavelength. So he has proven that light will shift the wavelength when they are passing through some molecules in discrete patterns. Discrete means not continuous. At the Indian Association for Cultivation of Science in Kolkata, he crafted a custom spectrometer. He designed a spectrometer from a telescope. He used a telescope, mirrors, and diffraction grating to capture subtle spectral changes. He was able to do a device, he created a spectrometer to prove that light will scatter or change its wavelength when they pass through some molecules. And his meticulous experiments on crushed crystals and liquids. He has experimented on crystals and liquids and confirmed inelastic light scattering. And he was awarded in 1930 Nobel Prize. In 1930, C.V. Raman got Nobel Prize. Raman's work underscored the power of careful observation and experimentation design. So, what is the lesson that you should learn? Meticulous attention to detail and unwavering dedication yield profound scientific discoveries. You don't have to have lot of resources. Even without resources you can still be able to achieve what you want to achieve if you have meticulous attention to the details and unwavering determination. He had no fancy things, he had no laboratory, but he was still able to do it. You have everything, why are you not able to achieve? Right? Have determination to achieve something great. Do great things, then only people will remember you. See, I will tell you one thing, guys. I will tell you one thing. If people have to remember you, you should come out of the comfort zone and do what others are not doing. Then only people will remember your name. Okay? And he is a hero, and people still remember him, and we are still talking about him. He is the real heroes. Now you are seeing YouTubers like me, and you are seeing Instagram influencers, and you are feeling like you have to become like us. There are great people, guys. Become like them. Okay? Now tell me the answer for this question. Now tell me the answer for this question. D doesn't have transition on B. Huh. D has transition on B. Tell me how many states you are getting. Tell me how many states you are getting. Take time and do it, okay? Shall I do it? Shall I do it? Check this. I will do it. Okay. First, pi naught, you separate out zeros and final states and non-final states. What are non-final states? This is E. So, non-final states are B, C, and E. Right. And what about final state? Final states are A and D. A and D. Right. Now try to find out pi 1. Now let us see if B and C can be put together. So for that you have to see what is happening for B and C on A and B, right? So B and C on A, B and C on A is going to B is going to E, and C on A is going to E. Both of them are going to same state. Both of them are going to same state, right? Now B and C on B, where are they going? B is going to C on B, and C is going to D. C is going to D on B. Now B is going to C and C is going to D. C is going to D. Right. So both of them can be separated because both of them are going into different partitions. So I am separating them out. Both of them have to be separated. So I am separating them out. Okay. So B and C can be separated. Now let us see if E can go with B. Right. E can go with B. How can I test it? BE on A. BE on A. What is BE on A? What is BE on A? So B on A is going to E. B on A is going to E, and E on A is going to E. E on A is going to E, right? Right. So both of them are going to same state. So you cannot separate them now. But let us see B and E on B. Let us see B and E on B, right? So B on B is going to C. B on B is going to C, and E on B is going to E. E on B is going to E, right? So one is going to C and the other one is going to E. One is going to C and the other one is going to E. So they are going into the same state. I cannot separate them now. Both of them are equivalent. C got separated. Now let's see. Now let's see about AD, whether they can be separated out or not. Okay. AD on A. AD on A. What is AD on A? AD on A. A on A is going to be, and D on A is going to be. Both of them are going to same state, so no problem. Now AD on B. A on B is going to A, and D on B is going to D. Both of them are going to the same state. Both of them are going to the same state, right? Right. Now let us see pi 2. Now let us see pi 2. Let us see pi 2. Okay. Now let us see if B and D can be combined. Let us see if B and D can be combined. Okay. So how can B and B can be combined? B and E on A. B and E on A. B and E on A. B is going to E and E is going to E. So no problem. Now B and E on B. B is going to C. B is going to C, and E is going to E on A is E on B is E. One is going to C, other is going to E. So one is going to C and other is going to E. Both of them are going separately, so they can be separated out, right? So B and E have to be separated out. Now we got B as a separate state, E as a separate state, C as a separate state. Now we have to decide about AD. Now we have to decide about AD, right? Now AD on small a on small a is going to B, and D on small a is going to B. Both of them are going to same state, right? Now A on A and D on B. Now A on B is going to A and D on B is going to D, which means they are going to AD. Both of them are going to AD, same partition, we cannot separate them out, okay? But there is a change here. From here to here there is a change. So but then the change says that all of them got separated and both these are not separated, right? Actually you have to do one more time. Even if you do one more time, you will get the same answer, so I am stopping it here. Actually when there is a change here, there is a change, right? You have to do one more time, so I am going to stop it here, okay? Okay, so now what do we get? BECAD, right? BECAD. Where is this? Okay, so we got, what are the states we got now? What are the states we got now? We got AD, we got B, and we got C, and we got E. Okay, now A and D on seeing A are going to be. A and D on seeing A are going to be. See this, A on seeing A is going to be, that is why I am writing it like this, right? Now A on B is going to be. A on B is going to be, right? Now B on small a is going to E. B on small a is going to E, right? And B on small c is going to C. B on small b is going to C, right? And C on small a is going to E. C on small a is going to E. And C on small b, C, is it done? 0 and 1 done. 0 A and B done. A and B done. A is done, B is pending here. In C, B is pending, right? So C on B is going to D. C on B is going to D. C on B is going to D, but D is here. Right? What about E? E on A comma B is going to A comma B, right? Now this is the final state, because A and D are final states. Now when we combine them, we get one final state, right? So this is the final state. Okay, everyone understood this? Everyone understood this? Everyone got it? Everyone got it? So if you observe it, you will observe something. If you clearly observe it, you will find something in this question. Can you tell me what was this question? Can you tell me what was this question? Can you tell me what was this question? Every A should be followed by a B. That is the question. We did it earlier. Every A should be followed by a B. Now when we minimize it, we are getting this. We did it in the previous examples. You can check it. Now what is this question? Every A is followed by two B's. Now we have simplified it and finally we got this. We did it, right? So this is sufficient. We have done enough questions. There will be no need to do more questions, however. But then what I want to suggest you is, take all DFAs that we have taken so far. Take all the DFAs that we have taken so far and convert them into minimal DFAs. Convert them into minimal DFAs. convert them into minimal DFAs. Okay, okay, okay. Now I will tell you how to identify a language is regular. One of the burning questions that you have been asking me right from the beginning is how to identify whether a language is regular. ठीक है? अभी से पार्टी शुरू होगी, अभी से पार्टी शुरू होगी, दरवाजे को घंटी मारो कोई ना अंदर आने पाए, आरबीआर को समझा दो म्यूजिक गलती से भी रुक ना पाए, टकर टकर जो फील करे वो जाके 2 कप कॉफी पी ले, जिसको डांस नहीं करना है जाके अपना बैस चलाए. ठीक है, जाके अपना बैस चलाए. ठीक है. नाउ वी विल सी हाउ टू आइडेंटिफाई ए लैंग्वेज इज रेगुलर. वी विल सी हाउ टू आइडेंटिफाई ए लैंग्वेज इज रेगुलर. ठीक है. एंड तेलुगु का एक रैप करेंगे, तेलुगु का रैप. ठीक है. तेलुगु का रैप क्या होगा? పోతా పోతా పైసలన్నీ పట్టుకపోతావారా, పెట్టుకున్నవన్నీ నువ్వు కట్టుకపోతావారా, పోరి పోరి అంటావు దాన్ని చుట్టుకుంటావారా, సక్కబోసి పెగ్గేస్తా ఆ ఆ ఆ ఆ. ठीक है. So let us see one of the motivational stories, then we will go about it. Have you heard about Homi Jahangir Baba, India's atomic energy program? He laid the foundation for India's atomic energy program. After earning his degree, his doctorate at Cambridge, he has done his doctorate from Cambridge. He need not return to India. He had a beautiful job and a high-paying job, but he returned to India to propose peaceful nuclear energy for India's development. As founding director of TIFR and Atomic Energy, he established in Trombay, he built world-class research facilities from scratch. But navigating funding and bureaucratic challenges is a very difficult thing. Getting funding for a lab back then in 1990s, in initial years of 1900s, getting funding for a lab was very difficult thing. You have to cross many bureaucrats. Still, he took it as a challenge and he recruited top scientists and fostered collaboration. He hired best brains of India, right? Now, his pioneering work in cosmic rays and quantum mechanics earned global recognition, and his legacy endures in India's nuclear institution. TIFR is so successful because of this one guy called Homi Jahangir Baba, the real hero. What is the lesson that you should learn? A clear vision and institution building can catalyze national progress in science and technology. I want to say Jai Hind, Jai Hind, Jai Hind. We have heroes like them, right? These are the real role models, not our Instagram influencers and not our YouTube influencers. These are the heroes that you should be learning about and that you should be aiming at, right? Not the influencers. Okay, I am not a motivational speaker. I am an inspirer. I achieved something in my life and I'm asking you to achieve the same thing. Okay, I am not a motivational speaker. Okay, fine. Now let us find out whether a language is regular or not. Let us find out whether a language is regular or not. So I will give you 3 rules. RBR rules to find whether a language is regular or not. RBR's rules to find whether a language is regular or not. Yeah, you can change your domain. Okay, so I'll give you 3 rules. I will give you first rule and I will give you second rule. 2A, 2B, 2C, 2D. You will be able to identify whether a language is regular or not. Okay, these are not the standard methods. These are the methods that I have invented so that students can answer the questions easily. If you go by pumping lemma, you will not be able to answer the questions. So these are my rules which I have invented so that you can easily answer the question. Okay, so now let us see. Oh my G, RBR sir, you taking classes at midnight. What about 4 a.m. wake up time? कभी कभी होता भाई, रात में थोड़ा सा लेट हो जाएगा, कभी कभी तो होता है, ठीक है, कभी कभी तो होता है। ठीक है, किरण भारद्वाज, थैंक यू। So, identifying whether a language is regular or not. RBR rule number 1. This is simple rule. You two will be knowing this, okay? So the rule is, if a language is finite, if a language is finite, then it is regular. Every finite language is regular. Let us say L1 is there. There are only two strings A, B, B. This is finite, so this is regular, right? Let us say L2 equal to A power n, B power n, such that n is less than or equal to 100. Again, this is finite, this is regular. Now let us see L3 equal to A power n, B power n, C power n, such that n is less than or equal to 10 power 10 power 10 power 10. So this is regular. So this is regular. This is regular, right? This is regular. This is regular. Okay. Crime gaming. So this is regular. This is finite, right? Why is it finite? It is finite. That is why it is regular, right? So they can give you something like this: L4 equal to A power P such that P is prime, and P is less than 10 power 10. Again, this is finite language. This is finite language, therefore it is regular. Finite language, therefore it is regular. Okay. Now let us see 2A, 2B, 2C, 2D. Okay. Let us see 2A, 2B, 2C, 2D. 2A. 2A says that every non-linear power is not regular. Non-linear power is regular. Non-linear power is regular. If I write like this, A power n, this is a linear power. A power 2n, this is a linear power. A power 2n plus 3, this is a linear power. A power 2n, B power 3n, this is B power 3m. This is linear power. There is no comparison between them, right? Now if I write A power 2n, B power 3m, C power 4k, again these are linear powers, right? If I write like this, A power 2n, B power 3m, C power 4k, D power 5d, 5l. Okay. So all these languages are linear. All these languages are linear, therefore they are regular. Therefore they are regular. All these powers are linear, therefore they are regular. If I write non-linear power like a power n square. This is non-linear. What is linear? Linear means the power should be 1. The maximum power of the variable should be 1. Okay? What is the help Subrashu? Sub, Subranshu. Subranshu. What is the help you want, Subranshu? I am 2023 MCA pass out. Don't know whether I should apply for GATE or not. Don't know. Don't have any technical job. Teaching in one college. What should I do? Prepare for GATE, Subranshu. You will be able to do MTech in MTech and your life will definitely change. Okay. Now, a power n square is non-linear. A power n factorial is non-linear. A power prime number is non-linear. नहीं तो a power composite is non-linear. Composite number is non-linear. Right. Now a power 2 power n. A power 2 power n. Whenever you see non-linear, all of these are non-regular. All of these are non-regular. All of these are non-regular. Okay. All of these are non-regular. Okay. This is RBR rule. RBR rule 2A. Rule number 2A of RBR. Okay. Now let us see RBR 2B. RBR 2B rule. When you are applying 2B rule, you have to be little bit cautious. You have to be little bit careful. You have to be little bit careful. 26 years is too young. Too young. You are not too old to do MTech. 26 is too young. Okay. 26 is too young. Okay. Okay. Fine. I will take 3 minutes of break and I'll come back. Just watch something meanwhile. I just need some fresh air. Okay. I've been teaching since morning, so I need some fresh air. Take 2 minutes of break. Okay. कभी भी पढ़ो, it is always 4 AM someday. मैं आपको एक चीज बताता हूँ, it is always 4 AM somewhere in the world. अभी वर्ल्ड में कहीं ना कहीं तो 4 AM तो बजेगा ही बजेगा. Imagine that now the time is 4 AM and you are in a different place where the time is 4 AM. है ना? Isn't it? It is always 4 AM at some place in the world. So it doesn't matter whether you study in the daytime or nighttime, as long as it is 4 AM, isn't it? And somewhere it is 4 AM. You check it out where it is 4 AM. Just as a experiment, you can do that, okay? So RBR rule number 2A, okay? Rule number 2A. So addition and subtraction can be done by context-free languages. Addition and subtraction can be done by context-free languages, but addition, subtraction, division and multiplication can be done by CSL, right? Regular expressions, regular languages, A power n, B power n, C power n. We will see that, okay? Regular expressions cannot be doing infinite addition, infinite subtraction, division, infinite star. See, we have already covered this. RBR rule number 1 is what? About finite languages. And rule number 2 is what? About infinite languages. All the infinite languages, okay? Here n is greater than or equal to 0, n is greater than or equal to 0, n is greater than or equal to 0, n comma m greater than or equal to 0, n comma m comma k greater than or equal to 0, n comma m comma k comma l greater than or equal to 0. Here also n is greater than or equal to 0, n is greater than or equal to 0, and prime number a power prime, all primes, all composite numbers. Here also n is greater than or equal to 0. This is a power 2 power n, okay? This is a power 2 power n. A power 2 power n. But when you are applying RBR rule number 2, you have to be little cautious. You have to be little cautious, okay? Now, don't blindly apply it. Sometimes there is a chance that some languages may be regular, okay? Some languages may be regular, even though addition is involved, okay? Let us say a power m, b power n, b power c, b power c, a power m, b power n, c power p, such that m plus n equal to p. M plus n equal to p, and n comma m comma p greater than or equal to 0. Is it regular or not? A power m, b power n, c power p, such that m plus n equal to p, m comma n comma p is greater than or equal to 0. Is this regular or not? Is this regular or not? Is this regular or not? This one is regular. Why is this regular? You take any value of m and n, you take any value of m and n, sorry, this is non-regular, right? This is non-regular because this addition cannot be performed by a finite automata. Finite automata cannot perform this addition, right? So addition can be done by context-free languages. So this language is context-free language. This language is not regular, okay? This is RBR rule number 2B, right? Now tell me about this. A power m, b power n, c power p such that m into n into m equal to p, n comma m comma p greater than or equal to 0. M comma n comma p greater than or equal to 0. Tell me about that. Very good. This is not regular. This is not regular, but multiplication can be done by CSL. But multiplication can be done by CSL. This is not regular and this is not CFL. Multiplication can be done by CSL. Multiplication can be done by CSL. Okay? Now tell me about this. A power m, b power n, c power p such that m plus n plus p is equal to 100. M plus n plus c is equal to 100. First rule clear nahi hua. हो गए ना? What is first rule? First rule is if a language is finite, then it is regular. All these languages are finite, therefore they are regular, right? And second rule में 2a क्या है? Linear power. All the linear powers are regular. All the non-linear powers are not regular. Now what is rule number 2b? RBR rule number 2b. Addition and subtraction CFL. Addition, subtraction, multiplication, division by CSL. Now we have seen two examples. Now tell me about this. A power m, b power n, c power n. How is the Josh, guys? How is the Josh? How is the Josh? We will stop the class when the date changes. You are ending the day with me and starting the day with me. The beauty of 12 a.m. is, do you know the beauty of 12 a.m.? The day ends there and a new day starts there. You are ending your day with me and starting your day with me, right? I feel so lucky that so many of you are ending and starting the day with me. Okay. A power n, b power n, c power p such that m plus n plus p equal to 100. So this language is regular. This language is regular. This language is regular. Why is it regular? This language is regular. Why is this regular? Very good. This is finite language. This is finite language. M plus n plus p equal to 100 is finite language. 0, 0, 100, 0, 1, 99, 1, 0, 99, 1, 1, 98. If you keep on writing like this is a finite language and so it is regular. And so it is regular. Okay. Now, a power m, b power n, c power p such that m by n equal to p. A power m, b power n, c power p such that m by n equal to p. Here there is डिवीजन इन्वॉल्व. When there is division, सर सेकंड का फर्स्ट रूल अच्छे से समझ नहीं आया. See what is linear. I think you don't know what is a linear expression, right? If I write like this, x plus 1, this is linear because power of x is 1. If I write like this, x square plus 1, this is non-linear because power is 2. Whenever the power is 1, whenever the power of a polynomial is 1, the highest power of a polynomial is 1, then that is linear. If it is more than 1, then it is non-linear. Okay. What about this? M by n equal to p. Clearly it is not regular. Clearly it is not regular. Clearly it is not context-free language. Clearly it is not regular, and clearly it is not context-free language. And clearly it is CSL. Why? Division is involved. Division is involved. Division is involved. Right? Right? इसका बताना. A power n, B power n such that m plus n equal to p, m comma n comma p greater than or equal to 0. M comma n comma p greater than or equal to 0. इसमें थोड़ा सा ट्रिक है. ये थोड़ा सा ट्विस्टेड क्वेश्चन है. थोड़ा सा सोचो समझो. ठीक है. a power m plus n, a power m plus n देखो, if I take m equal to 1, n equal to 2, then m plus n will be equal to p, which is 3. It is little bit difficult to understand. Try to answer it. Try to focus on this. M and n can be anything. If I add m and n, I will get some p. So what is this language? This language is a star b star, a star b star, right? I can take any number of a's, I can take any number of b's. Only condition is m plus n equal to p. Only condition is m plus n equal to p. If I take 10 a's here, 10 b's here, then 10 plus 10 equal to 20, and 20 is a p. 20 is a p. Therefore, this is regular. Therefore, this is regular. I think you are feeling sleepy. I think you are not. Shall I go for one more hour? 2 बजे तक करेंगे क्या? Shall we go for one more hour? ऊ बोलेंगे या ऊ बोलेंगे? ऊ बोलेंगे या ऊ बोलेंगे? I am ready. I am always ready. ठीक है. ठीक है. Now we will see one model. Now we will see one model. A power m b power n such that a power m b power n such that m plus n equal to 10. What is this language? A power m b power n such that m plus n equal to 10. What is this language? What is this language? ठीक है. एनीवे डेट बदलने वाला है, कल से एक्सटेंड करेंगे. ओके. फ्रॉम टुमारो क्लासेस विल बी फ्रॉम 11:15 to 11:15 to 1:30. ठीक है. From tomorrow classes will be from 11:15 to 1:30. ठीक है. So this is finite, right? This is finite language. This is finite language, right? Right. This is finite language. Therefore, this is regular. Okay. Fine. We will discuss the remaining models tomorrow. We will discuss the remaining models tomorrow. It will take some time. It will take some time. We are almost at the end of regular languages. एंड नहीं है, बहुत सारा पढ़ा है. ठीक है. ओके. Okay guys, we will turn off now. Okay.